So imagine that we're given the square root of 100. And I ask you, what is the square root of 100? Well, you need to find one number that multiplied by itself gives you 100. In that case, it's 10. Therefore, 100 is a perfect square. Okay? If I were to give you the square root of x squared, I want you to give me a variable that multiplied times itself gives you x squared. And that will be x. Because x times x, following the rules of exponents, gives you x squared. So imagine you have square root of x to the fourth. Well, square root of that is x squared. Imagine you have x to the sixth is x3, because x times x is x squared. X squared times x squared is x to the fourth. X3 times x3 is x6, because remember, we're adding the exponents when we multiply. In the case for the number, 10 times 10 is 100. So these are all perfect squares, okay? Perfect squares, okay? Well, now let's think about what do we do when they're not perfect. Just know that these all have a little 2 over here, but we don't see the 2. When you have a radical like this, the 2 is there. We just don't write it. So, what do we do when the radical is not perfect? Well, let's talk about first numbers. Okay? Imagine you have the square root of 20. I want you to simplify this. Oops, I ate the L. Simplify it. Okay? Well, you can do several ways. You can rewrite this radical as one perfect and one not perfect, meaning one number being a perfect square and one number not being a perfect square. So I can have 4 times the square root of 5. Okay? Because 4 times 5 is 20. If you're not able to see this 4 and this 5, you can rewrite this 20 and find the factoring tree and say 2 times 10, 2 times 5, right? Now check this out. Once you do this, square root of 4 is 2. Square root of 5, it does not have any, so it stays, okay? Well, if you were not able to see this, and you're going to use the factoring tree, what do? When you have two numbers that are the same, you group them together because you're looking for squares. And from that group, only one comes out and the leftover stays inside the radical. You end up with the same answer, okay? Now, if you're given the square root of 20, the simplified version of that is 2 square root of 5. Let's do another example. Let's say we have 80. Square root of 80. I want you to simplify that. Well, 80 is a little bit of a larger number. So if you go, take 80 on the side, do your factoring tree, 10 times 8, 2 times 5, 2 times 4, 2 times 2. You want to make groups of 2. So I have one group here, and I have one group here, right? So from each group, only one comes out. So I'm going to bring 1, 2 from this group right here, from this group. And then I'm going to bring another 2 from this group right here, only one. And then the leftovers, the numbers that I did not use, go inside the radical. And that is 5. So 5 will stay in here. Now I need to multiply these two. So this gives me 4 square root of 5. So the simplified version of square root of 80 is 4 square root of 5. Well, what about if you didn't like the factoring tree? and you said, well, I can clearly see that 16 times 5 gives me 80. So I'm going to rewrite this as square root of 16 times square root of 5, a perfect and a non-perfect. Then you ask yourself, well, what is the square root of 16? I know that's 4. Square root of 5 does not have, so that stays inside. And you end up with the same answer both ways. It's whatever you're able to see better. If you're able to work out with the factoring tree, go ahead. If you're able to just look and split the number in two, one perfect, one not, you can do that as well. It does not matter which way you do it. Let's see. Another example. If we have square root of, this one is a little bit easier, 200. Okay, you can go ahead and do your factoring tree. You can do that on the side. 2 times 100, 2 times 50, 2 times 25, and then 5 and 5. I always start with 2 because it's easier to split a number in half versus doing higher numbers. So I'm going to make groups of the same number. Cannot make a group with this 2 over here because I don't have another 2. From each group, I'm only going to bring 1 out. And the leftover stays inside. Then I multiply the outside. That gives you 10 square root of 2. So the simplified version of square root of 200. Oop, my square root looks really bad. Of 200 is 10 square root of 2. Well, in this case, let's say you don't like the factoring tree. You don't like this over here. And you automatically are able to see that the square root of 100 times square root of 2 gives you 200. Therefore, you also notice that 100 is a perfect square. So you just say square root of 100 is 10. And square root of 2 does not have any. So it's like that. And that's your answer. You end up with the same thing. You have a choice which way to do it. Well, now let's look at the variables. Imagine you have square root of x to the 10. Let's just have that little review. Well, we know that is half of that. So the square root of x to the 10 is x to the 5. Well, what happens when I have square root of x to the 11? Excuse me. Well, 11 is not an even number. Therefore, you cannot divide it by 2. So you want to ask yourself, how many times can 2 fit evenly into 11? Well, that's 5 times. So x to the 5 comes out. And what is your remainder? X to the 1. Another way to look at this is you can say 2 divided by 11 goes in 5. 5 times 2 is 10. That leaves you 1. The 5 is the outside exponent of the variable. Oops. And then the 1, the remainder, is the inside exponent of the variable. Okay, so the remainder goes for the exponent in the inside. Another example that we can look at is imagine square root of x 13. Well, the answer to that is x6 in the outside, square root of 1 in the inside. Why? If I do 2 divided by 13, I'm talking about the exponent. I'm using 2 because the index here is a 2. So then I go 2 into that is 6. 6 times that is 12. I'm left with 1. The 6 is the exponent of the outside. The 1 is the exponent of the inside. Another example that we can look at, let's see if we have we can put more than one variable in the inside. So we can say x to the 7, y to the 10. Well, remember we're doing dividing by 2. So if I divide 2 by 7, I'm going to get x3 in the outside and 1x in the inside. If I divide the exponent for the y, it's 10. Divided by 2 is 5. So I'm going to have y5 in the outside. I don't have no y's in the inside. Then I'm going to rewrite this as x cubed, y5, remainder 1x. Okay, well, let's see if we have another example. Imagine we have A5, B4, C2. Okay, I'm going to simplify this. And I'm going to divide 5 by 2. That gives me A2 in the outside and 1A in the inside. I'm going to divide 4 for the B by 2. That gives me B2 in the outside. No B, excuse me, no B in the inside. Then I'm going to divide C, the exponent for C, and that gives me 2. So, C, oops, I'm sorry. Getting confused. 1C in the outside. Then I'm going to rewrite this so it looks a little bit better. Square root of 8. Okay. Imagine we have, I don't think I'm going to put that many variables in the inside. Imagine we have x4, y 8, and then z3. Well, I'm going to divide the power for the x by 2. That gives me x2 in the outside. The power for the y by 2. That gives me y4 in the outside. And I'm going to divide the power of the z by 2. That gives me 1c in the outside, with a remainder of 1c in the inside. Okay, so this is the answer for that one. That one, the answer for that one. Okay.